Once you've completed Chapter 9, you should be able to recognize some common functional groups, what the functional groups that are present and characteristics of them that are in different molecules found in food, such as fats, oils, proteins, and carbohydrates. We're also going to look at the differences between proteins, amino acids, and essential amino acids, and look at how to calculate the amount of calories that you're gaining from the food based on the grams of fat that are present, carbohydrates, and proteins. And finally, we're going to look at some similarities and differences between combustion, respiration, and photosynthesis. So what exactly are functionalized hydrocarbons? Well, in Chapter 8, we looked at hydrocarbons, which, if you remember, contain just hydrogen and carbon. So we looked at what an alkane was. We looked at what alkenes were, at alkynes and aromatics. So remember, alkanes contain only single bonds. Alkenes contain at least one double bond. Alkynes are a triple bond, and aromatics, those tend to be ringed structures with alternating single and double bonds. Now we're going to look at functionalized hydrocarbons. And functionalized hydrocarbons are where we add in other types of atoms. So it's not only carbon and hydrogen. Now we're going to add some oxygen, some nitrogen, and it can include other things like sulfur as well. But we're going to focus mainly on oxygen and nitrogen. So let's look at some functional groups and define them. So we've said that they can contain other types of atoms, but it's the arrangement of those atoms in the organic molecule. And these are responsible for the properties of the molecule, as well as the chemical reactions that they will undergo. So some of the functional groups that we've already looked at are our alkanes, so single bond containing molecules, alkenes and alkynes, double bond and triple bond. Now, when you're looking at these different representations, the R that is written, that is just representing any carbon-containing group past that functional group. So we'll see different arrangements and different ways that they're connected, but those R's just mean more carbons past the functional group. So in this chapter, we're going to look at a couple of these particular molecules or functional groups. So one of the functional groups is going to be an alcohol. So an alcohol contains carbon-containing molecule that is attached directly to an oxygen and a hydrogen. And this is what we call an alcohol. Alcohols, the name of it ends in OL. And a really common one of these is ethanol. So ethanol is the alcohol that is in alcoholic beverages. And the eth part refers to two carbons. The AN means it's all singly bonded. And then the OL at the end tells us that there is this O oxygen bonded to a hydrogen. So as an example, our ethanol is going to have two carbons with hydrogen single bonded with an oxygen and another hydrogen attached to it. So that would be ethanol. So that R group, if we're referring to ethanol, is going to be the two carbons and the hydrogens attached to them. Okay, then the OH is what represents our alcohol group. Okay, we're also going to be looking at carboxylic acids. So carboxylic acids, they also have an OH group, but they are bonded to a carbon attached to an oxygen with a double bond. So this whole part needs to be present in order for it to be a carboxylic acid. And then there is another, again, R group, which means it's attached to carbons. Okay, so carboxylic acid, one that you may know, is acetic acid. So that's vinegar. Vinegar has this carboxylic acid group attached to it. Okay. So do notice that there is differences in our functional groups depending on how these atoms are attached. If we have just two carbons with that carbonyl, it's called a carbonyl, carbon double bonded to an oxygen. Okay, so there's no OH in this ketone, which makes it a different type of functional group. So it's still got this carbon double bonded to the oxygen, no OH, it's between two carbons. That makes this a ketone. If we have carbon double bonded to an oxygen with just a hydrogen, again, this is a different type of functional group called an aldehyde. Okay, so the different arrangement and identifying them is going to be based on how those atoms are attached to each other. So you need to look carefully, and you can use this infographic to help you recognize different functional groups. If we have an oxygen with no carbon double bonded to it, just an oxygen between two carbons, then that is called an ether. And again, this has different properties. All right, so back to the ones that we're going to focus on. We're going to focus on alcohols, carboxylic acids, amide. So an amide is that, again, that carbonyl, carbon double bonded oxygen, but now it is attached to a nitrogen, NH2, or a nitrogen containing compound. So that makes it an amide. And we'll see these in proteins. We also have amines. So this is a nitrogen attached to our carbon, but again, no carbon double bonded oxygen present, and that makes it an amine. We do have some functional groups that contain sulfur, so thiols contain sulfur. These tend to be very strong smelling compounds, so if you think of rotten eggs or skunk, okay, that is a thiol that is making those strong smelling compounds. Okay, so recognizing functional groups depends on how the carbon and other elements are attached to each other, and it's kind of matching. So you match it up with how they are bonded to each other to recognize different functional groups.